Alright guys, today what we're looking at is how to describe motion when the object is changing its motion. It's speeding up or it's slowing down. So when that happens, you'll notice that all of these graphs here are curved. So that means that when you've got changing speed or non-uniform motion, the slope of a distance time graph is curved. So a changing slope means that there's a changing speed for that particular object. So let's look at the examples we did in class. So for the first example, I've got a graph where I got a very, very low slope at the beginning, and at the end it's pretty high, and it's going towards the north. So what's going on here, slope is increasing towards the north, so the object is speeding up or accelerating towards the north. Its speed is getting bigger, northwards. For B, a little bit different though. I start off with a low speed, and just look at the slope, don't care about the 4. A very low speed, low slope, and by the end, my slope is very high. But it's going the other way, so here, my slope is getting higher towards the south. So in other words, the object is accelerating towards the south direction. So both of these are accelerating towards different directions. Here's towards the north, here's more south or backwards. And you know it's speeding up too because the slope is going away from the x-axis, away from the x-axis. Now here, for C, I've got a really, really high speed at the beginning, high slope, and by the time you get to the end here, the slope is really, really low. In other words, my speed is very low. So what's going on here is my slope is going down, so my object is slowing down. In other words, it's decelerating. And the object was initially moving towards the north. So going to the north, coming to a stop. D, we've got a really, really high speed, but this time the speed is going down. So in other words, we're going towards the south. So these guys are going really, really fast southward, gradually coming to a stop with a low speed. So we're slowing down, decelerating, and the object at the beginning was moving to the south. So again, curved line. So this is leveling off. So when you see leveling off, it means you're stopping. Now, what we want to do is we want to be able to calculate the instantaneous speed. I want to figure out how fast something is going when it's accelerating. Now, the thing is, when we've got acceleration, we've got this curved line. I can't find the slope of a curved line, so we've got to kind of improvise. So what we do is we draw a tangent, a special line that kind of represents the slope of the curve at that moment in time. And when we draw the tangent, we find the slope of the tangent, and the slope of the tangent is representing the speed of the object at that time. So let's check out an example. So here I've got an object. It's accelerating. You can see the curve is going upwards. And I want to know the speed at 4 seconds. So I put a point at 4 seconds, draw a nice tangent, so it's kind of evenly spaced on both sides, on either side of 4 seconds. And then you want to find the slope of this tangent line. So here, my rise is going from 0 meters up to 10 meters. So y2, 10 minus y1. 10 minus 0. y2 minus y1. For the run, I'm going from about 2.5 to 5. So my rise is going to be x2 minus x1. x2 is 5 minus x1, which is 2.5. So 5 minus 2.5. And you're going to end up with 10 over 2.5. And that gives you a speed of 4 meters per second. So the object was going at 4 meters per second at 4 seconds in time. So at that time, that's how fast it was moving. So let's look at a couple of examples. So what I have over here is 2 examples. Uh-oh. No, don't crash on me now. So I've got 2 examples. I'm going to pause for a second.